Assalamualaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NAVS Home School. I am Sabreena Haque, assistant teacher of science, National Ideal English Version School, day shift. Dear students, today I am going to take a chemistry class for class 10 student on the based on chapter 9, and this is the part 2 of the chapter. The name of the chapter is acid base balance. So let us move for our today's topic. Dear students, in our previous class we already learned about the acid, and today we will start base and alkali. Now come to definition of base. Metals or metal like reactive radicals, oxide and hydroxide that undergo reaction with acid and produce salt and water are called base. This is the definition of base, and there is some examples like calcium oxide plus hydrochloric acid. When calcium oxide is a base, it is a metallic oxide. When it is react with acid, then it produces salt, calcium chloride and water, and this is neutralizing reaction. And potassium hydroxide, this is a hydroxide of a metal, and it react with sulfuric acid, produce potassium sulfate and water. Potassium sulfate is a salt. Now come to next one, ammonium hydroxide react with hydrochloric acid, produce ammonium chloride and water, and ammonium chloride is a salt. So all these things that shows the characters of base. That means calcium oxide is metals oxide, potassium hydroxide is metallic hydroxide, that all are react with acids, various acids, and produce salt and water. Then ammonium ion and phosphonium ions etc. radicals are reactive like metal. This you have to remember. This is an important portion. And metallic ions like sodium, potassium etc. combine with non-metallic ions like chlorine, sulfate etc. produce ionic compounds, sodium chloride, potassium chloride, sodium sulfate, potassium sulfate etc. Similarly, that ammonium and phosphonium ions combine with chlorine, sulfate, chlorine ion and sulfate ion produce ionic compound, that is ammonium chloride, phosphonium chloride, ammonium sulfate, phosphonium sulfate. That means it also act like metal. These two radicals, ammonium and phosphonium, that two act when it react with substances like chlorine ion and sulfate ion, it also act like metals. That's why it when it react sodium ammonium hydroxide react with hydrochloric acid, it also produce salt and water, and the reaction between acid and base produce salt and water is called acid base neutralizing reaction, and it's also known as neutralization reaction. And it is said that acid neutralize base and base neutralize acid, and come to the alkali. And in our previous class we already learned about the base and alkali. Then hydroxide compound of metals or metal like reactive radicals that are soluble in water is called alkali. This is the definition of alkali. And when we read in class 8, that time we have learned all alkali are base, but all base are not alkali. That means there is a characteristics of alkali. A compound can be alkali if it contains hydroxide ion radicals and it dissolve in water. That if these two characteristics is absent, that is not known as alkali. Now come to sodium hydroxide is alkali because it has hydroxide radicals and it dissolve in water, and ferrous hydroxide cannot be called an alkali because although it has hydroxide radicals, it does not dissolve in water. That means if any of the characteristics is absent, that is not alkali, that is only base. And calcium oxide is base but not alkali because it is not has hydroxide radicals, and which thing has hydroxide radicals and dissolve in water, that are known as alkali. That's why it can be said that all bases are not alkali, but all alkalis are bases. That is very much important line and an important topic of the question also. And there are many basic compound in our household. Toilet cleaners in our house are base containing sodium hydroxide, and glass cleaner that containing ammonium hydroxide are base. That is, you have to remember their compound. Now come to properties of dilute base. The solution prepared by adding comparatively smaller amount of base in larger amount of water is called dilute base. This is the definition of dilute base. Students, it is not the weak base, but it is dilute base, because the molecules of base is lesser than the water molecule. Now come to litmus test. Like the acid, there also litmus test occurs, that small amount of sodium hydroxide solution, after taking small amount of sodium hydroxide solution in a test tube, and if we put a red litmus paper, it turns to blue. That means acid turns the blue litmus paper red, and base turns the red litmus paper into blue. Base turns the red litmus paper into blue, and this is a properties of base. That means basic solution, that means base solution turns the red litmus paper into blue. Now come to filling. And acid test slippery, and here acid test sour, and here the fillings of the base is slippery, and if we touch the base then it will be filled slippery. And we know the soap we use, the shampoo we use, the main component is base, then that's why it's feel slippery, and that is the properties of base also. Now come to dilute base in reaction with metallic salt. And when the base react with ammonium nitrate, ferrous nitrate, ferric nitrate, ammonium nitrate, ferrous nitrate and ferric nitrate, zinc nitrate, etc., metallic salt dilute base produce the metallic hydroxide. Mentionable here, we have to use the nitrate salt apart. Now metallic chloride, metallic sulfate and metallic sulfate salt will produce from the same result. Now come here, reaction between dilute sodium hydroxide and ammonium nitrate. Here if you observe, ammonium nitrate react with sodium hydroxide, produce ammonium hydroxide and sodium nitrate. And come to again the next reaction between sodium hydroxide and ferrous nitrate, and it also produce here the reaction ferrous nitrate react with sodium hydroxide, produce ferrous hydroxide and sodium nitrate salt. Now come to next one, that is reaction between dilute sodium hydroxide and ferric nitrate. Here ferric nitrate and sodium hydroxide when react with each other produce ferric hydroxide and sodium nitrate, and all the time that hydroxide which is produced, that will be precipitate. That means it will be accumulate in the bottom of the beaker. Now come to next one, reaction between dilute sodium hydroxide and copper nitrate. It will produce copper hydroxide and sodium nitrate. Look, there after every hydroxide in this type of reaction, the arrow is given which is downward. That means this compound accumulate in the bottom of the test tube or in the beaker, that will be precipitate. Now reaction between sodium hydroxide and zinc nitrate and produce zinc hydroxide and sodium nitrate. And if you observe the total reaction, it is similar. The product of the reaction is similar. Now come to reaction between alkali. That means sodium hydroxide also alkali, because all alkali are also base, and ammonium salt. When Ammonium chloride and sodium hydroxide make a chemical reaction. It produces ammonia, sodium chloride and water. Now come here, there they show the reaction between ammonium chloride and different types of alkali and base. When ammonium chloride react with potassium hydroxide, it produces ammonia, potassium chloride and also water like the sodium hydroxide. Now come to next one, ammonium chloride react with calcium hydroxide, produce ammonia, calcium chloride and water. Now come to next one, ammonium chloride react with calcium oxide, produce ammonia, calcium chloride and water. Now come to next one, then role of water in chemical properties of alkali. Both compound potassium hydroxide and sodium hydroxide have ion, but when they are in solid state, these ions are not free, and the moment they are dissolved, they become fully ionized and produce free hydroxide ion. Only hydroxide ion in the solution carries negative charge. Look, when potassium hydroxide dissolve in water, it produce potassium ion and hydroxyl ion, and when sodium hydroxide dissolve in water, it produce sodium ion and hydroxyl ion. Ammonia gas is the summation of ammonia molecules. When ammonia gas is dissolved in water, their reaction produce ammonium ion and hydroxide ion. However, ammonia dissolved only partially in water and very small number of hydroxide ion is produced. Therefore, ammonia solution contains ammonia molecules and water molecules and a small number of ammonium and hydroxyl ion. And these characteristics of an alkali solution depend on the proper presence of mobile hydroxide ion. That means which alkali dissolved partially in aqueous solution are weak alkali. Like the weak acid is also known as weak alkali because it dissolve partially in the water solution, but strong alkali because become fully ionized in aqueous solution, and that is a very much important characteristics of the base. That means weak alkali solution consists the lesser number of hydroxide ion than that of the strong alkali. Now come to corrosive properties of concentrated acid and alkali. Concentrated acid and concentrated alkali are highly corrosive. They can corrode cloths and skin. They spoil ice if they go into the ice. Concentrated acid and concentrated alkali are added solely to water and turns into dilute solution as they dissolve completely. And if by any chance concentrated acid and concentrated alkali come into contact with our body, the spot must be cleaned with time again and again, and then you should inform your teacher. Now here they give a task. Here experiment of weak and strong and weak acid or strong and weak alkali. We know that in the electrochemical cell we use acid and alkali solution, and if you observe properly, when we use the strong acid, that will produce more electricity, and when we use the weak acid, that will produce less electricity. Now come to next one, that is strong acid provide more hydrogen ion or proton in the aqueous solution than the weak acid. This excess amount of hydrogen ion conduct more electricity in the solution. That is why the bulb in the strong acid gives more light. On the other hand, weak acid supplies lesser number of hydrogen ion, that means proton, in the aqueous solution, resulting in lesser amount of electricity conduction in the solution. So the bulb given less light, weak acid given lesser amount of proton, and strong acid produce greater amount of proton. Similarly, through this type of experiment we can also prove the strong base produce more number of hydroxyl ion and the weak acid produce or mild acid, weak or mild acids produce lesser amount of hydroxyl ion. Now come to the conception of pH. pH is used as the unit of determining the nature of an aqueous solution, a measure of the acidity, alkalinity and neutrality of the solution. This is the definition of pH. If you observe, the P of pH is small letter and H is the capital letter. Here pH solution is the negative logarithm. You have to remember this. This pH is equal to minus log, it is this H is the number of hydrogen ions, it is protons, then H will be capitalized. Why H is capitalized beside the small p? Because H is represent the hydrogen. This H is represent the hydrogen. That's why it will be in capital letter. Then H plus express the molar concentration of hydrogen ion. And that means how many moles of hydrogen ion or proton in there in the solution. In 1 liter solution, that will be the H plus, the presence of hydrogen ion in the 1 liter distilled water is 10 to the power minus 7 mole. You have to remember that. Then pH value of distilled water is minus log of hydrogen ions is equal to minus log of 10 to the power minus 7. So pH value of distilled water is only 7. This is the value of distilled water, and this is the neutral position of pH value. When there is any ions within the third bracket in the molarity unit, this is the concentration of the ion is expressed. Then if the acid is added to the distilled water for this region, the number of hydrogen ion increase 10 times make it 10 to the power minus 6. That you have to remember. Then the value of that time, it will be pH is equal to minus log of 10 to the power minus 6 is equal to 6. The more the molarity of hydrogen ion and the lesser value of pH will be. Then if the alkali is added to the distilled water, the hydroxyl ion of the alkali will undergo the reaction with hydrogen ion or proton and lessen the number of proton. For example, due to adding alkali in water, if the number of hydrogen ion or proton drops down, it will be 10 to the power minus 10 mole per liter. Then pH value will be 10. It will be 10. That means pH value will be raised from 7, and pH value of the alkaline solution is more than 7. If this you have to remember, 7 is the neutral position of the pH scale, and if the value is less than 7 it will be acidic, and is the value of more than 7 it will be alkaline. That you have to remember. Now come to measuring of pH. This is the pH scale given in your book. That color is not proper in my print, but it is proper in your textbook, and this is a pH scale. By seeing the color we can determine which is the pH value and what will be. The 7 is the neutral position, from 6 to 0 is the acid, and from the 8 to 14 is base. Now come to measuring system. We have already learned how to measure pH of a solution from the molarity of hydrogen ion. Now we will learn then how to measure it in experiment through the involves of universal indicator, pH paper and pH meter. Now come to universal indicator, that you have to learn. That is, universal indicator is the mixture of various acid and base indicator. Universal indicator turns to different colors from one different value of pH, and there is a chart of colors for different value of universal indicator. This is known as universal indicator and color chart. And students, this is the picture of universal indicator color chart. To know the value of pH of an unknown solution, add few drop of universal indicator in the solution and then compare the color of the solution with the standard color chart of the determine the value of pH. And now come to pH paper. pH paper is used for knowing the value of unknown solution. Add a small piece of pH paper in the solution and it will change its color, and there is a standard color chart for the various pH values. Compare the color with the pH paper with that standard color chart and determine the value of pH. Now come to pH meter. Here student, this is the picture of pH meter, and pH meter is used for knowing the value of pH of an unknown solution. Inserting the electrode of the pH meter in the unknown solution, the value of pH can be known directly from the digital display of pH meter, and it is a very useful method for now. Now come to the litmus paper. Litmus paper is easily available and cheaper alternative to know the approximate value of pH. The litmus paper is red when the pH value is less than 7, and the color of blue when it is more than 7. Dear students, I have finished my today's topic, and you have to do your SW, and as SW you have to write the properties of base and definition of base as your homework number 7, and submit on Saturday from 9 AM to 3 PM. Thank you. Allah Hafiz.